Okay guys, you should have your 3.5 quadratic function models solving quadratic equations handout. So first we're going to talk about the key ideas. Really, what does it mean to solve a quadratic equation? So I've written down just an example here of a quadratic equation. I know that it's quadratic because it is a degree 2, and I know it's an equation because there's an equal sign. So anytime we want to solve a quadratic equation, we have to make it equal to 0. So x squared plus 5x plus 4, because I brought it to the other side, is equal to 0. Once we're at this point, and this shouldn't be new, this is a review from grade 10, we need to either factor or use the quadratic formula. Okay, and a reminder, our quadratic formula, x equals negative b plus or minus square root b squared minus 4ac. Oh, my camera's moving. Over 2a. Okay, now you can use the quadratic formula anytime, and you can factor, and they will give you the same answer. However, if you can factor, do that because it's always much quicker. So take a second, work through the first two problems. Determine the roots for each equation by factoring. Notice that this question didn't say solve, it just said use the roots. Since solving, we've said, is when we're letting it equal to 0, letting something equal to 0 is graphically finding its roots, right? Or the x-intercept. So, exact same thing. Solve this one by factoring, solve number 2 by using the quadratic formula to 2 decimal spaces. You can find the answers for both of these on Schoology. Okay, moving on to question number 3 on the back, word problems. So with word problems, generally, you're going to replace your y value and you're just going to be solving. You just have to interpret the word problem to get to that point. So a water balloon is catapulted into the air from the top of a building. The height h of t in meters of the balloon after t seconds is h of t is equal to negative 5 t squared plus 30t plus 10. Okay, before we even get started, I like to make sure that I have a visual understanding of what this looks like. So I did a little diagram for you guys here. Hope you can see that. Yeah, you can. Okay. So I know that the y-intercept is at 10 because the c value in the given equation is 10. And I know that the parabola opens down because my a value is negative. Now I don't really know where it hits the x-axis. I don't know where the maximum is, but I know that that's the general shape. Okay? What are the domain and range of this function? So normally with a parabola, of course, my domain would be x is an element to the real numbers. However, in this specific situation, we're not even using x as our independent variable, it's t, and it's a situation of time, so we're not going to consider time that's negative, that's over here, okay? And we're not going to consider time once the balloon hits the ground. So we're really looking for between time 0 and whenever it hits the ground. And whenever it hits the ground is at a height of 0. So for our domain, we are going to, I'm going to cover this side too, we are going to let h of t equal 0. Now, that's just a solving question. That's what we talked about before. So in this case, I use the quadratic formula because factoring this, even though I can common factor 5 out, factoring this was difficult. Actually, not really possible, so that's why I did that. And once you use your quadratic formula, you're going to find that t is equal to either negative 0.31 or 6.31. Okay? Since we talked about that you can't possibly have a negative time, that doesn't make any sense, we are going to use the 6.31. So our domain is between 0, including 0, so square bracket, and 6.31. The range. So the range, let's go back to our little diagram, goes from 0, a height of 0. We're not going to consider, if the water balloon's not going through the ground, so we're not going to consider negative heights. So from 0 all the way up to its maximum. Okay? And last week we looked at maximums, so we're going to use that same method, our negative b over 2a. Okay, so our t is equal to negative b over 2a. We find that that's equal to 3. If you plug in 3, so h of 3, you're going to find that t is equal to 55. Therefore, our range is 0 to 55. Okay, the next question, part B. When will the balloon reach a height of 30 meters? Okay, so it's asking for a time and giving us a height. We are going to, so this is our equation, we're going to replace the height with 30, okay? And then we're going to solve an equation for t. So, just like before, make sure it's equal to 0, so that involves bringing the 30 to the other side. And if we bring the 30 to the other side, it's 10 minus 30, so negative 20, okay? Use the quadratic formula. And I have two answers. So I have 0.76 and 5.23. And that makes sense that I would have two answers because the ball will reach a height of 30. Let's go back to this diagram. Both on the way up, let's say this is about 30. So on the way up and on the way down. Okay? So therefore, the balloon will reach a height or reach 30 meters at 0.76 seconds and 5.23 seconds. All right, to fold this sheet so it fits. Last question. A factory is to be built on a lot that measures 80 by 60. The lawn of uniform width is equal to the area of the factory, and it must surround it. How wide will the strip of lawn be, and what are the dimensions of the factory? All right, so this is a really good example of a thinking question. So we know that it's uniform width. I'm going to draw another picture so you can actually see what I'm drawing because it's kind of dark quality here. So we know if it's uniform width, then it's x here and x is here, okay, where x is the unknown width of the lawn, okay? We also know that our area of the factory has to be equal to the area of the lawn. So we're going to write our area of the factory, so that's this area right here, okay? And the area of the lawn, that's the surrounding area, okay? Kind of like this rectangular donut shape here, have to be equal. So we're going to write those in terms of x. Okay, so the area of the factory, if this is 80 from here to here, and this is x and this is x, this distance here has to be 80 minus 2x. Okay, so 80 minus 2x. Okay, similarly, if this is 60, this is x and this is x, this happens to be 60 minus 2x. Oh, and my camera's moving. Okay. Which is essentially length times width. That's how we got that. Okay, area of the lawn. You can do this a couple ways. This is the way that I approached it. I took this piece, then this piece, and then this piece, and this piece. Okay, so the piece is in pink. The length of this is 60, so I'll write 60, and the width of this is x, so 60 times x. That's the area of the pink piece. And since there's two of them, I'm going to do all of that multiplied by 2. We're going to add that to the purple pieces. The purple pieces have a width that's equal to the width of the factory, okay? And I know that the width of the factory is 80 minus 2x, so plus 80 minus 2x times the, times x, because that's the length of it right here. And since there's two of them, multiply that by 2. Okay. Now you are going to write that those are equal. You should have room on your page, but since I kind of drew this whole diagram here, I don't have room, but on your page, you can write that. Let me make sure you can see this. You are going to equate your area of the lawn, so that's this part, and your area of the factory, okay? This happens to be a quadratic equation that we have to solve, where we have to solve for our x, okay? So once you have this, at this point, all you have to do is shower power, so that's expanding, then simplifying, and you're gonna get to this line, okay? If I were you, I would pause the video, make sure you can work through that all on your own. At this point, you are going to factor out an 8, then you're gonna just do simple trinomial factoring. You're gonna find that your two possible values for x are 60 and 10. All right, it cannot possibly be 60 because if we go back to our question, if the length here is 60, the length here is 60, you're not gonna have a width of the lawn that's 60. That doesn't make any sense. So it has to be 10. Whoop. Okay? If this is 10 and this is 10, then, and this is 80 all the way across, then the width here is 60. If this is 60, then the width here is 40. Okay? So finally, therefore the lawn is 10 meters wide and the factory is 60 by 40.